pi there. Algebra you need to know before going to college. Without further ado, let's begin. So essentially, these are a set of questions that you can answer along with me that you should probably be able to answer, and you should be able to answer if you are about to go to college or in college. So just basic algebra stuff, and you must be confident about this. Also, by the way, if like you need a PDF file of this whole thing, whole worksheet, it will be in the link. It will be in the link in the description down below. So let's get it going. Okay, this one. So part 1 is simplifying expressions. So this involves a lot of laws of exponents. So let's answer this first problem. So we have here quantity 2x raised to 5. So wait a second. So this one, quantity 2x raised to 5 y squared times z raised to negative 3, this, times 2 squared x raised to 4 y raised to negative 2 z raised to 6. So how do we solve this one? So essentially we just multiply and add the exponents of those with similar what you call this, either similar number here or similar variable. Just take note that when it's not present, like in this one, that just means that this one is 1 there. Okay, so let's do this one. So this will be equal to 2 raised to 1 plus 2 times x raised to 5 plus 4 times y raised to 2 plus negative 2, or just simply 2 minus 2, and then z raised to negative 3 plus 6. Upon simplification, this will just be, so in this first one, we will have 2 cubed, or simply just 8, right? So we'll have here 8, then x raised to 9. Take note here that this one is y raised to 0, and any number or variable raised to 0 will just be equal to 1 there. So we can just leave it as it is. Then z raised to negative 3 plus 6 will be z cubed. So this will be the answer for the first problem. Okay, it's not what I expected. Maybe this one. There you go. Okay, so by the way, this will be quite a lot, so make sure to drink plenty of water as you watch this one. And so let's go to the next one. So this is 3 cubed x raised to 6 y cubed z raised to 4 all over 3 x raised to 5 y z squared. So how do we do this? So a while ago we multiplied. When we multiply, we add. When we divide, we subtract, basically. So again, just subtract the exponents of the one with the similar numbers or similar variables. Actually not similar, same variable or same number. And again, recall that when the exponent is not present, like here and here, that just means that we have here 1 and 1. Okay, good. So we'll have here 3 cubed minus 1 times x raised to 6 minus 5 y times 3 minus 1 times z raised to 4 minus 2. Okay, and this will just be equal to, take note here in the first one that this will become 2. So 3 squared will be equal to 9. Then 6 minus 5, that's x, it's just x raised to 1. Y, 3 minus 1 will be 2. And then 4 minus 2 will be squared. Z squared. I hope this one is correct. So yeah, let's just box the final answer. So there you go. So that's the answer for the second item. And this one and the third one. So for this one, take note that unlike a while ago that we immediately subtract the exponents of the same variables, same numbers from the numerator and denominator, this time take note that we first have here parentheses. So remember PEMDAS, we start with that one. And we have an exponent here that we must first apply. So how do you apply that? Basically, you distribute this one to each one of these. Similarly, we do with this one. Okay, so let's just do that one. So let's put a line here. So in the first one, we'll have 2 cubed. Okay, fine, let's just write it as 2 cubed. Then next will be this cube times this one. That would be... So just recall that when you distribute this one, basically you multiply the exponents. So we'll have here 3 times 3. So this will just be a raised to 9. Next, 3 here and -3. So we'll have here b raised to -6. And then 3 times -2, that will be c raised to -6. Apply similarly in the denominator, just take note that this one is negative. So we'll have here a raised to -6, b raised to -4, c raised to 2. There you go. Yep, that's correct. So next, we apply the similar tactic we did a while ago. So we'll have 2 cubed. For 2 cubed, just simply 8. Actually, we're lacking space here, so why not move it a little bit here? There you go. And then for a, we'll have a raised to 9. Just be careful here. So again, when we divide, that's subtraction, but we have negative here, so we have 9 minus -6 here. For b, the same story applies. We have b -6 minus -4 here, and then c -6 minus 2 out here, right? And then let's just simplify this thing, I think. Yep. So here, so we have 9 minus -6, so that's basically 9 plus 6, or 15. There. Next, we have here -6 minus -4, so that's -6. -6 plus 4, yeah, so that would be -2. And then we have your c, -6 minus 2 would be c raised to -8. And just recall that when the exponent is negative, this actually goes in the denominator. So we'll have here, for the final answer, we'll have 8a raised to 15 all over b squared and c raised to 8. So that will be the answer for this problem. So these are the problems or items or exercises that you should be able to answer when simplifying expressions. This will be important as you go on along some calculus courses, okay? Okay, good. So next is factoring polynomials. So this one is also very important in college. So let's start with the first one. So for factoring polynomials, our goal is to have factors, basically, to be able to write, let's say, this expression to something like this, then this, or maybe this one, something like that. So first we have what we call common monomial factoring. So basically, if we have this divided by sum and differences, what you do is you try to observe what variables or numbers are similar in each. Like in this one, we have a's in all of this. We have b's and we have c's. So when we factor this out, what we factor out is actually, again, the variable. So let's focus first on a. So this one, and this one. what we choose to factor out is one with the least degree or least power. In this case, that would be a squared, okay? Because if we factored out a cubed, then there will be left here inside a raised to negative 1, which is not what we want. Okay, so yeah, not what, okay, so to expound on that, not what we want, because we will have here 1 over a, and that doesn't really look like a polynomial. Okay, so we factor out to call this a squared. Then for b, what we factor out, the least power is 3. So we factor out that one. And then for c, the least power is 4. Okay, so factor out that. So what will be left in the original expression is for the first term, this one will have here 1, since basically this here is this. So it was all, the whole term was factored out. For the second one, there will be left an a and a b and a c, right? So since the exponent here are 2, 3, and 4, this one is 3, 4, and 5. Okay, then for the last one, there will be left a 2. So we weren't able to factor out 2 because there weren't any 2 in the first two terms. And we'll have here b, right? Yeah, so that will be the answer for this one. That would be the answer because we can't really factor anything here already. So that's pretty straightforward. This one is where it gets more interesting. We have what we call difference of two squares. I hope that rings a bell. So essentially, if we observe that this first term and the second term is a square, which it is because 16 is 4 squared and 25 is 5 squared, then we have a special factoring for that one. So let's just write this one as 4x squared minus 5y squared. And yeah, so according to difference of two squares, this will factor out into 4x minus 5y times 4x plus 5. Essentially, you subtract these two and then you add these two to obtain this one, and the one a while ago is for this one. And that's basically it, since we can't factor out this one. So it's actually pretty straightforward. Okay, there. So again, this next problem is a difference of two squares problem. But the good thing about it is that whenever you see a1, your eyes should light up, because take note that any number raised to 1 is equal to 1. So we have here 1 squared equal to 1, 1 raised to 4 equal to 1, and so on. So in this case, take note that the one here can be written as what you call this, 9 squared, right? Yeah. And this one here can be written as x squared squared. So we can write this one as 9x squared squared minus, just for technicality, minus 1 squared. So I hope you got that one, and then apply difference of two squares again. So we have here 9x squared minus 1, 9x squared plus 1. And from here, take note that this one cannot be factored anymore. You know what? I might not explain that one, but try to think about that one. So let me put here. Why can't you factor this? Why is this not factorable? Okay. But for the other one, this one, take note that this one is a difference of two squares. Again, as we can view, again, 1 here is 1 squared, and here the 9x squared can be viewed as 3x squared. So if we do that one, so we'll have here 3x squared minus, again for technicality, 1 squared times 9x squared plus 1. Whew. Okay. Then apply the difference of two squares again, so we'll have 3x minus 1, 3x plus 1, and 9x squared plus 1. So as you can see, you can apply difference of two squares infinitely many times actually. And this is the final answer. There. Yeah. Just to take note in this one, the reason for this one is not just because it is not difference of two squares, okay? So if you're thinking about that, that's not the answer. My hint would be look at this square here. Okay, number 4. This is another difference of two squares, but this is a good problem since it shows that the difference of two squares does not only apply to like monomials like this one, it can also apply to square of binomials like this one. So applying difference of two squares here, we will have here x plus 3 plus y plus 2 times x plus 3 minus y plus 2. And if you want, we can simplify this one. For the first one, we have here x, y, and then 3 and 2 can be added here to obtain x plus y plus 5. And then for the second one, we have here x minus y here. So we have x minus y. And then for the constants, we have 3 minus 2. So that will be 1. And that is the factored form for this one. Oh, dang it. This is the hard part with good notes, man. It's like sometimes it doesn't get what I want, but oh there. But it's fine sometimes. Okay, so that is for the fourth item. The fifth item, this one. Obviously it's not difference of two squares anymore. But this is what we call like sum and difference of two cubes. But in this case it is sum. Later it will be difference. So yeah. Essentially here you just need to recall the formula given by if we have a cubed plus minus b cubed, this is equal to a squared, then this will be minus plus, I think. And then multiply the two terms, two base variables. Then the last one is really this one, I think. Let's look at this. Yeah, I think that's one. So applying it out here, take note that we can write this as 2x, I think cube, right? Yep. Plus z 4 here cube. And then apply the one that I have written a while ago. So we'll have here first you add these two, and then you first square this first one. So we'll have here 2x cube square minus, again recall that from what I've written a while ago, this one, these two must be opposite, minus the product of these two, so that would be 2x cubed times z raised to 4 plus the square of the last. So we will have here, just copy the first, and then for the second one we'll have here 4x raised to 6 minus 2x cubed z raised to 4 plus z raised to 8. I hope that is correct, and that's basically it. There. Good. Okay, so that's how you apply it. And again, like a while ago, take note that this sum and difference of two cubes also applies when this one is a binomial. So applying it here, just take note that one here can be viewed as 1 cube. That's the beauty of it. We can view it as 1 square a while ago, 1 raised to 4, and now as 1 cube. So by doing that, we'll have here x minus y minus 1 times, not to be confused, this one is the first term essentially, so there's times the square of the first one, so we'll have here x minus y squared. Then again, opposite, this one is minus, this must be plus, so we'll have here x minus y times 1 plus square of the last one, which is essentially just square. Yeah. I don't really want to simplify this one anymore. Let me just write it as this one. Let's just copy it and just remove the 1 here, since any number or expression multiplied by 1 is just 1. So I don't know with your teachers, but with this, for me, I guess I'll accept this one. I don't know, maybe you should really simplify this one. So just simplify this one. Okay, so let's go here. So number 7, we have x squared minus 2x minus 3. So this is where things get more intuitive than a while ago that it's just straightforward. So we have here what we call quadratic trinomial. When we encounter this one, the key is to find numbers that when you multiply, you get this, including the negative here, and when you add, you get this. So what can you think of? Well, for this one, we can actually use, take note that negative 3 times 1 is equal to negative 3, and negative 2 is equal to negative 3 plus 1. So with that information, this is just simply x minus 3 times x plus 1. So that's usually the trick in applying or in solving factoring quadratic trinomials. So that's the answer for this one. So this trick this method of factoring, this one comes a long way. Of course, this item is pretty basic, pretty standard. But as you go along the way on studying math, especially college, you'll need more practice on this factoring of this one. Okay, let's move this one. And we have here this. Take note, like a while ago, this is the usual form when you encounter quadratic trinomials, but you can also have expressions like this where the principles on quadratic trinomials apply. Just observe that this is actually equal to a cubed b squared minus a cubed b squared c minus 42 c squared. So again, take note, you can view this as one variable, just like that one. So it's like we'll have x squared minus xc minus 42c. I got kind of confused because there's a c here, so I thought there was a typo in what I have written, but essentially we apply the same thing. Just to be clearer, you can view it as this one. So essentially we need to think of two numbers that when we multiply, again we get this, and then when we add we get this. So a good candidate for that one would be, for this one, we can have negative 7c times 6c, right? And when you add that one, we'll have negative 7c plus 6c out here, which is negative c. So that means that this one is equal to a cubed b squared minus 7c times a cubed b squared plus 6c. And I think this is the factored form for this problem. I might double check later. I can't remember writing this in my answer key. But yeah. Okay, I think that's good. So just a couple of more items. Oh man, that's a couple more. That's 4. See, I also feel the pain in solving math items, even though that's what I do for a living. But anyways, so we have here 2r squared minus r minus 3. So this again is a quadratic trinomial, but this time we have here 2 is the coefficient of the term with the degree 2. So for this one, usually one can solve it directly like a while ago, just with some modifications, but personally I prefer when this one is 1. So I apply a method called slide and divide method. By slide and divide, so the first step is to slide. So what you do is slide this coefficient here and multiply it in the denominator. So we'll have here r squared minus r minus 6, and then solve this like the usual. And this one is easier to factor for me, so it's easy to check that this will be r minus 3 and r plus 2, since if you add negative 3 and 2, you get the coefficient for this one. If you multiply them, you get the coefficient for this one. And then after you factor that out the usual way, this is where divide comes in. So remember the number that we slide here, essentially we divide it into 2 factors here. So we'll have here this one divided by 2 divided by 2. And we have space. Yeah. So this one will become r minus 3 over 2, and then r plus 1. And take note here that we don't really like fractions. So what we do is if there is a fraction here that can't be simplified anymore, we move the denominator back to the coefficient part. And so we'll have 2r minus 3 times r plus 1. And you can check that that is the correct answer for this one. Like if you multiply it, we'll get this one. Oops. Let's use a different color. So this will be 2r minus 3 times r plus 1. Yeah, there you go. So let me just drink water since I'm doing this in the morning and I'm really hungry right now, or whatever. Okay, so that's 3 items for this part. Okay, so we have here again slide and divide method. So again, we slide this one here. So we have your slide and divide. So by doing that, we'll have x squared minus 4x plus 1. Oops, plus 4. And then from here, if you look at this one, this is actually what we call a perfect square trinomial. Actually, you can notice it just by looking at this, but you might did not notice that. That's why I still apply slide divide method. So essentially, what I mean by that is that when you encounter a perfect square trinomial, these are the cases we're in. Like a while ago, and if we view this one, we try to think of numbers that when we multiply, we get the last term, and when we add, we get the second. This first. In here, you'll notice that that number is actually the same. Like in here, we get 2 times negative 2 times 2, to be honest, and then to be particular, and then negative 2 plus negative 2 is negative 4. So this is what we call a perfect square trinomial. Another way to view that is if you observe that this can be written as square the first and the last term, and then the second one is again this one is negative 2, and then the middle term is 2 times the product of the first and the last term. So we have here x times negative 2, right? So when that happens, we just simply have let's call this x minus 2 squared. There. Basically, this is x plus negative 2. So it's just like the sum of these two terms. You form it into a binomial and then you square it. So are we done? Not really, since again we applied slide and divide method here. So we slide 4 there, we still need to divide 4 out here. So we have here divided by 4. And we'll be left with x minus 1/2 squared. But this one cannot be simplified anymore. The fraction cannot be simplified. So again, we slide this back here. And so we'll have 2x minus 1 squared. And that's basically the factored form of this one. So there we go. And so last 2 items. For this first item, just take note that you can apply slide and divide here again, but alternatively, there are cases that when you immediately notice that this one is perfect square trinomial, you can immediately start with that one. Because for this one, take note that you can view the first one as 2n squared. The last one would be negative 3 squared. And then the middle term will become 2 times the first term and the last term. So how did I know that? Well, it comes with practice. Well, that's a good thing because you can simply practice and be proficient at this one. It's not innate ability. So applying a perfect square trinomial, this will become 2n minus 3 squared. Okay, and yeah, that's basically the factored form of this one. And finally, for the final item for this part, so we'll have your a squared plus ab plus 5a plus 5b. This one is what we call, the last one is what we call factoring by grouping. So essentially, we're used to factoring monomials, but not really binomials. But in here, that's what we're gonna do. So essentially, in this part, we try to group terms. So let's group this one first. And so we'll have here a squared plus ab, mean, this can be anything. This grouping can be anything. You can even group probably this one and then this one, and you'll still get the same result. And then we group the last two terms. And from here, we factor out a term and them. I think the space that I allotted is not enough. Let's just... okay, whatever. So take note that here we have a common term of a, so we can factor out one a there, since this one is a raised to 1. And then here we have a common factor of 5. So factoring that one out, we'll have here a times a plus b plus 5 times a plus b. Now here's is where the trick comes in factoring by group. Take note that this one is a common factor in this binomial out here. How do you, this one? A plus 5. We have a common factor of a plus b. So you can also factor that one out. Maybe I can put it here. Yeah, just put it here. So this one will become, if you factor out a plus b, we'll be left with a plus 5. And yeah, and so this one is already the factored form of this expression. So it's actually a pretty slick move that might arise whenever you encounter larger polynomials, like plenty of sums and differences, especially when you have 4 terms. Actually, that is when factoring by grouping usually arises. So those are the answers for parts 1 and 2. I might end here since it's already quite long. I thought I could be able to answer all the questions in here, but we'll do that in a separate video. So for the meantime, digest this and make sure that you know how to do this right before going to college. If you have any questions or concerns, just tell that in the comment down below. And besides that, have a great day.